Okay, hello all you crazy people out there. My name is Dragonite, and welcome back to 3D games in GameMaker Studio 2. The last video was all about setting up a 3D projection in a room in GameMaker. And this video is going to be all about taking the next logical step and putting things in that room. Again, same as the last video, standard disclaimers apply. This is one of the more advanced things you can do in GameMaker if you don't have a decent amount of programming experience under your belt. I'm not going to say you should stop watching, but I will say that you should probably shore up on that sooner rather than later. So this is where the difficulty starts to ramp up. I have 4 lines of code, 6 if you count the empty line in the comment at the top. This is the camera's draw event. This is what the project actually looks like now. That was what I showed you before, is just a little demo of what I'm going to have by the end of this video. This is just a, This is just a layer of tiles in a room, and it is being drawn with a 3D projection instead of a 2D projection. So to start things off, let's go back to I'm going to be putting everything in the camera's create event. If you're making an actual game, you probably want to separate the camera from other objects in the game, such as floors in the wall and tiles and stuff like that, and objects. But for the purposes of this tutorial, I will just put everything in one game object. This video is going to have more code in it than the last couple have. I'm going to maximize this as well, because I prefer to have the space than to have nice workspaces. The first thing I'm going to do is not directly related to creating objects that you're going to put on the screen, but it's something that you're almost always going to want to have. There are 2 functions in GameMaker Studio 2. Well, there are more than 2 functions in GameMaker Studio 2, but there are 2 functions that I'm concerned with right now. GPU set Z test enable and GPU set Z write enable. These have to do with what is known as the depth buffer. And the depth buffer is the mad science way of saying that things that are in front of other objects should be drawn in front, and things that are behind other objects should be drawn in the back. In almost all cases, you're going to want to have this turned on. You're going to want to have this set to true in 3D and false otherwise. I didn't include it in the last video because I wanted to really focus on the 4 lines of code that had to do with the camera. I'll take a deeper dive into some cool things you can do with the depth buffer later, probably. The next 6 lines of code that I'm going to write is going to have to do with something called a vertex format. The vertex format is going to be the basis of everything that is drawn in 3D in GameMaker. And also everything that you ever draw in a computer, period, but in normal everyday 2D use, it's something you don't have to worry about yourself. I'm going to add a couple lines which say vertex format position 3D, vertex format add normal, vertex format add text chord, vertex format add color, and finally vertex format equals vertex format end. So everything on a computer that passes through the graphics card is composed of polygons, as you probably know. Every time a new console generation opens, Sony and Microsoft like to crow about how their new console can push more polygons than their rivals and crunch more floating point operations per second and all those industry buzzwords. And a polygon, in almost all cases in the modern day, means a triangle, because a triangle is 3 points. It's the simplest geometric shape that can't be subdivided into anything else. If you tried to cut a square or a pentagon in half, you could always work it down to triangles. You could cut a square to get 2 triangles, but no matter how hard you try, if you cut a triangle in half, you're just still going to have 2 triangles. This video is where the complexity is going to start to ramp up. I'm going to start talking about things like math terms and geometry and vertex buffers. And I'm going to do my best to explain each of those things when I get to them, but if you already understand things like basic geometry concepts and what happens on the graphics card when you actually draw something, that will give you a tremendous advantage. Alright, where was I? Likewise, a triangle is composed of 3 points, 3 vertices. I'm sure I don't have to explain that one. And each vertex inside the computer is just a collection of data. And the vertex format exists so that you can define what types of data go into each vertex, as the name implies. The first and most important one is the 3D position. If you don't include the 3D position, you are going to have a rather difficult time drawing anything. The next three in this list, the normal, the text chord, and the color, these are all optional. Although in a vast majority of cases, you're going to make use of them one way or another. I'm going to include them here because I want to talk about them in the future, in the near future. Color I'll be talking about later on, soon enough. Each vertex can have a color that it's blended with. If you've ever used something like one of the draw sprite extended functions and you can specify a color to blend a sprite with, you have taken advantage of vertex color. This is just what it does under the hood. Text chord I'm going to talk about in the next video. That has to do with applying textures, and the normal is primarily used for lighting. And I want to talk about that eventually, but there are a few things that I would like to go over before we get to that point. So to finish up, we end our vertex format. This is what it's defined as, and we're going to save that to a variable. I personally find it a little bit weird that you don't define vertex formats like this, like you do with some other structures in GameMaker, and you instead save the value of the index of the vertex format at the end. I have a suspicion I know why this is, but I don't know for sure, and in any case, it is what it is. Let's move on. So the next thing that we're going to do is define a vertex buffer. And a vertex buffer is what contains the actual data that you are putting on the screen. This is what you're actually drawing to the screen. So I'm going to, because I know I'm going to forget, I'm going to come back to the default room. For now, I'm going to turn the tile layer off. Actually, no, I'm not. I'll turn it off later. I'm probably going to forget to turn the tile layer off when I actually mean to, but that's an embarrassment for later. So we're going to define a vertex buffer by saying, I'm going to call it just vbuffer because I'm going to be typing it out quite a lot, and I don't feel like typing vertex buffer with an underscore out every single time. Vertex buffer equals vertex create buffer. And immediately following, vertex begin. How do you spell buffer? vbuffer. And the second argument that it's going to take is the vertex format. Vertex begin is when you can actually start adding data to a vertex buffer to be drawn on the screen. It takes the index of the vertex buffer that you created, which is, as I said before, there to define the kind of data and the order that you wish to add it to the vertex buffer. So the first thing that I'm going to demonstrate before I create the checkerboard grid that you saw at the beginning of the video, I'm just going to create a square. And a square is composed of two triangles. And I'm going to think about the square in terms of a starting point and an ending point in the room. And just for the sake of not having a bunch of magic numbers floating around everywhere, I'm going to say, oops, not 400 to 400. The starting point of the square is going to be 400, 400 in the room, and the ending point of the square is going to be 600, 600. So that's a square. So, out of the box in GameMaker, when you want to add stuff to a vertex buffer, you have to add your data point by point. And in fact, not only do you have to add your data point by point, vertex by vertex as it were, you have to add them by each individual piece of data at a time. There are a number of ways you can make this less painful, but you have to walk before you can run. So I'm going to add the data point by point. Firstly, vertex position 3D. Every time I type out vertex buffer, vbuffer, I find a new and exciting way to misspell it. And as you can see at the bottom, it takes 3 arguments, aside from the vertex buffer itself. It takes an X, a Y, and a Z position. I'm going to feed it X1 and Y1 as its position, and I'm going to feed it 100 as its Z position. It's technically a magic number, but I'm not going to want to mess with that in this tutorial, so I'll leave it as it is. Next, vertex normal. You know what? Copy, and I'm just going to paste it instead of trying to type it out. For the vertex normal, that takes another 3 values, another 3 coordinates. It takes a normal X, a normal Y, and a normal Z. That is a vector. Again, that has to do with the way light is reflected. I'm going to get to that later. For the time being, I'm going to just feed that 0, 0, and positive 1. And I'm going to leave it at that. Thirdly, vertex text chord. You can't misspell if you copy and paste something that's already spelled correctly. That's going to take a U and a V value.
Hey.
I'm going to leave that at 0, 0 for now. Again, I will talk about this in more detail when I make a video on texturing things in 3D. And I'm just including this data now because I want to make a point to come back to it in the future. Lastly, vertex color, or if you prefer color with a U. I am personally not a big fan of redundant vowels, but if you want to spell it with a U, that's up to you. Vertex color, this should be familiar enough. If you've used any of the other drawing functions in GameMaker, it takes a color value and an alpha value, alpha being transparency, with 0 being fully transparent and 1 being fully opaque. For the color, I'm just going to say C_white, and for the alpha, I'm going to make it fully transparent, fully opaque. I rehearsed this in my head to make sure that I didn't screw that one up, and I did it anyway. To start with, I'm just going to be drawing a white triangle, and later square. This is one vertex. All this is 1/3 of one triangle. Generally speaking, I recommend making a script and calling it something like vertex add point. This is what I did in my original video on 3D in GameMaker. And then you can call vertex add point. I forgot to copy and paste. And you would give it all of this data all in one shot. So x1, y1, 100. For the normals, it would be 0, 0, 1. For the text chord, it would be 0, 0. And for the color, it would be C, white, and 1. And then inside the script, you would do basically this. Let me type this out real fast. Okay, here we go. This is just taking a batch of repetitive code, a batch of long and arduous and repetitive code, and wrapping it up in a script so that you can call it nice and easy like this. That's just a general software development practice, DRY, don't repeat yourself, that sort of thing. I'm going to comment that out for now, and I'm going to come back to it later. First, I'm just going to create the other two vertices in the first triangle by hand, because I want to show what's going on. The only thing that is going to be different about these vertices is the x-coordinate. Everything else is going to be the same. The normal, the textures, both of those being unused. The color, which is going to be white either way. If you can't visualize in your head what I'm creating here, here's a little diagram. There's the square I'm going to draw. And there's the square cut into two triangles. And that there is the first triangle that I have created just here right now. So I'm going to start with that. When you're done adding stuff to a vertex buffer, you need to call vertex end. That's okay. I need to copy and paste the variable name again. You need to call vertex end. And that essentially seals up the vertex buffer and makes it ready for drawing for the computer by the game. And to draw the vertex buffer, I'm going to come back over here to the camera. And the only thing I need to do here is, after the camera projection has been set up, vertex submit. And that's going to take 3 arguments. One being the index of the vertex buffer that we created. One being the primitive type. There are a few different ways you can send information to the graphics hardware to be drawn. The most common one is PR_triangle list. There are also triangle fans and triangle strips, which have their uses, but that's a story for another day. And if you want to literally just draw lines and not triangles, there are line lists and line strips. Those have uses if you want to draw, for example, a wireframe. And finally, there's the point list, which I have yet to find a use for.
Hey.
I'm going to be going with the triangle list because, as you can imagine, I am creating a list of triangles here. and the texture, which for now I'm going to just leave at -1 to indicate no texture. Using textures on things in 3D is going to be most likely the topic of the next video. So let me run the game now, and I really hope this works, because I've gone how long without running the game? There we go, that is a triangle. And as I was going to say, it would be really embarrassing if this does not work. But congratulations, that's your first triangle. That's like the hello world of computer graphics, I suppose the analogy would be. And you can see, for one simple triangle, you need 12 lines of code, or in my case 14 because I included spaces. Old versions of GameMaker provided you some degree of abstraction when it came to creating graphics to be drawn in 3D. GameMaker Studio 2 does not. You are literally adding your information to a vertex buffer, 1 unit of 32-bit floating point information at a time. Of course, that's not to say that it has to be. You can do things like this function here. You can say vertex add point. You can create a script like this, and it will combine essentially these 4 lines of code into one, which is much nicer to deal with. At the end of the day, you almost certainly want to load your 3D model information from a file. I made several videos on that quite a few years ago. Those videos are still completely valid. I'm not planning on remaking them. That sort of thing would allow you to create a 3D model in something like Blender or Model Creator for GameMaker or whatever, and just import it in one function call. But like I said, you need to walk before you can run, so I'm going to be starting here. Let me recreate that triangle using my new shiny and fancy vertex add point script. I say that's pretty nice. We combine 12 lines of code into 3. Now for the second triangle. I'm going to copy and paste this 3 more times. I'm going to be drawing points x2 and y2, followed by points x1 and y1, followed by, once again, the origin of x1 and y1. Did I say that the last time? The one before this was x1, y2, as you can see on the screen right now. And if I run the game again, we will now have, instead of a triangle with 3 points, we will have a square with 4. Okay, that's pretty nice. If you want to start messing around with color is pretty straightforward. You can, for example, let's make the second triangle blue. You can also mess around with transparency as well. Transparency in 3D is a strange beast. There are some odd, for lack of better terms, visual glitches that can happen if you're not careful about how you use transparency in 3D. And for the most part, I recommend just not using transparent surfaces in 3D, unless you know what you're doing. Anyway, there's our square. It's got 2 colors, blue and white. Each triangle doesn't have to be a solid color. If you want to, for example... that's not what I meant to type. I meant to type C. I believe I had aqua in mind. And for the last one, how about C, green? If you want to have colors smoothly blending over a triangle, you can do that. I think that's quite nice. That is called vertex coloring. You can do some interesting things with it. For the time being, I'm going to leave the second triangle as fully blue. I suppose this is analogous to the draw rectangle color, draw circle color, those sorts of drawing functions in 2D. You can blend multiple colors over a shape. Now, this is the fundamentals of drawing stuff using vertex buffers in 3D in GameMaker. I do want to take it a step further in this video. And I do want to draw the checkerboard grid that I was showing off at the beginning. So I'm going to comment out everything I just wrote. And this time, instead of creating a single square composed of 2 triangles, I'm going to be drawing a series of squares in a loop. The grid is going to be the same size as the room, so it's going to be the same size as the tile layer, which once again, I'm going to turn off because I'm going to be drawing something else in its place. Let's close the room so all that stuff can go away. Let's also F12, so I have a little more space. The loop is going to take the form of... This is my for loop. I'm going to be iterating over the room, both height and width, and I'm just going to be creating a series of squares. I really hope I don't have to explain every single term in this for loop. The curse continues. The telephone continues to ring while I'm trying to record a GameMaker video. It's a different number that calls almost every single time, and yet it's always the same scam. God, it's leaving a message. I heard something about call this number to verify your account. That's gotta be a scam. It's a different number every time, but it's always a scam. Oh man. Anyway, if you've made it this far into a video on 3D and vertex buffers, I'm going to take my chances that everyone can understand this for loop. So, as before, I'm going to be creating a series of triangles, which are going to be combined into squares. So I'm just going to copy and paste this. And instead of saying x1, y1, x2, y2, I'm going to say I and j as my x and y coordinates. For x1, y1, for x2, it's going to be I plus 32 and j. I plus 32 and j plus 32. 32 is just the size of the square that I'm drawing. Again, that's a magic number, but it'll be good enough for this video. Oops, didn't mean to hit Control-Shift-S. I plus 32 and j plus 32. I'm sorry, not that. That would have been a mistake. And the second triangle, I, j plus 32. I did it again. Okay, that looks good. So this is the same thing as before, except that the squares are different sizes. 32 by 32 instead of 200 by 200. The colors are still the same. This looks misaligned. And I know that's going to get on my nerves, so I'm going to just change the indentation so that the normals and texture coordinates are all in the same column, and that's easier to read. Again, series of triangles combining to form squares, which is going to form a grid. 100% of the time, when you create vertex buffers through code, it's going to be in a loop like this. This could be if you want to create an actual grid. I typically keep a couple different grids around in my projects for debugging purposes. Or if you want to read model vertex information out of an OBJ file or something, you would create a script that iterates over the contents of a file in a loop and creates data to put into a vertex buffer that way. I usually hesitate to say that you'll never do something in code, but creating triangles one by one in a manner such as this is well, if you do that, you're setting yourself up for a world of pain, let's put it that way.
Hey.
The checkerboard colors, if I run my lesson plan project, which is literally what I called it, you can see that the checkerboards are squares instead of triangles instead of triangles, covering half the squares. That's just how I chose to do it. This is just a little bit of math. The heuristic I used for that is, let me write it out. If the square is being created at both an even x and y coordinate in the grid, then it's going to be colored blue, otherwise it's going to be colored white. And since the grid is of size 32, I'm checking to see if, instead of the cells being an even multiple of 2, they're just an even multiple of 64. And then, instead of hard coding the color values, you're going to have the color values based on a variable. Here we go. Now now it's a nice checkerboard instead of triangles. That's it. You are well on your way to drawing stuff in 3D in GameMaker. There are, admittedly, many ways to mess this up, especially when it comes to the vertex format and the order in which you add data to a vertex buffer. I'll be talking about texturing and shaders and lighting and all sorts of fun stuff later on. So if you're interested in all those things, feel free to stick around. I'm going to try and do this regularly for about the first time in about 4 years. Oh, and one more thing, because this is going to become important about now. Everything you draw in 3D has to come after you set the camera projection. This was the rule in old versions of GameMaker, it's still the rule now. For that matter, you could write your own rendering engine in OpenGL, and it would be true there as well. You need to draw everything after you set the camera projection. There are two schools of thought on this. One is that the only object that is set to visible in the entire game is the camera object, and everything else is drawn like with either a loop or a with statement or something like that. The other school of thought is that you proceed as normal in GameMaker, everything is visible, and the camera just exists on a layer in the room with a higher depth value, because when you draw things in rooms in GameMaker, and this is true in both 2D and 3D, things are drawn essentially bottom up. So things with a higher depth value are drawn first, and things with a lower depth value are drawn last. If you want to force something to be drawn first, you could give it a very high depth value. If you want to force something to be last, you could give something a very negative depth value. I am a fan of doing the first thing that I said, which is having the only object visible in the game being the camera, and drawing everything else through the camera. I feel like that gives me more control, and there are fewer points of failure of accidentally putting something on the wrong depth layer. But to each their own. When I start making more involved scenes in 3D in this tutorial series, I'll probably talk more about that. So that's it. You are well on your way to drawing things in 3D in GameMaker now. There are plenty of places where this can be screwed up, especially in the Vertex format. There's a reason that I'm very adamant about understanding what's going on when you follow tutorials as opposed to just copying and pasting code, because when things inevitably break, you want to be able to fix them without just copying the error message into the comments of my videos and expecting me to fix it. To this day, that happens more often than I'd like it to. Anyway, if you want the code, I will have a link to the GitHub where I'm going to be throwing this in the description of the video. I will try to remember to add some more helpful comments before I do that. This has been the beginnings of drawing your own stuff in 3D in GameMaker. I hope you all enjoyed that. I don't have a Patreon, but if you're feeling generous, there is a tip jar in the description of the video as well. And I will see you all later.